Okay, right. This will be the uh, our first video. So we start on what we have left last time, and last time we discussed about the Rankine cycle, and I hope you remember that we discussed about four components starting from the boiler, then turbine, condenser, and the pump, and also we discussed about the cycle, Rankine cycle itself, and this number 1 to 2 is the compression, isentropic compression in the pump, and 2 to 3 is the heat addition, constant pressure heat addition in the boiler, then 3 to 4 isentropic expansion in the turbine, so where the work is generated in here, and then 4 to 1 heat rejection, right, constant pressure heat rejection in the condenser, right. So I hope you remember these things, and after that we discuss about the each of the component heat addition and work out those things using the enthalpy. Then we work on these two examples, right. I think, as I remember, I stopped in this place, right. So the next session is reheat Rankine cycle. What the difference in this one is, instead of having one set of turbine, you have two set of turbines. Now this one stage, then you have another stage. So basically this is the one turbine that attach in the same shaft, but you have two set of fan sections, right. So first set of section in here we called that one as the high pressure. Now this part is high pressure, and then we have the low pressure part, right, low pressure part. So what the difference in here is, once the steam passes through the high pressure turbine, it's directed back to the boiler and heat it again. That's why we call as a reheating. Heat it again, then directed back to the low pressure turbine, right. So the other components are the same, boiler, the condenser, and the pump, all are the same. Only difference is the turbine. You have two sections. Sometimes you have three sections. You have high pressure turbine, you have then intermediate pressure turbine, and you have low pressure turbine, right. So simplicity, we consider only two set of section where you have high pressure section and the low pressure section, right. So in between you have we have heating, reheating action in here, right. So that's the difference in Rankine cycle. So why we are doing this one is, the power plant can increase their efficiency by reheating. That's why we are doing this reheating. And the so with reheat, a power plant can take advantage of the increased efficiency that result with higher boiler pressure, and yet avoid low quality steam at the turbine exit. That means normally in here exit of the turbines, exits are it's we keep high quality steam at the turbine exits, right. So if we look on to the TS diagram, so this is the number 6 to 1 is the boiler action, first boiler action, where we adding the heat, right. Then 1 to 2 is the first set of turbine, that's in high pressure turbine. You have the isentropic expansion in the first set of turbine. Then 2 to 3 is again the boiler action, right. So we are directing back to the boiler and heat it again. So this is again the Q in, right. So you have a Q in here, 1 to 6, 6 to 1, Q in here, and 2 to 3 also Q in, heat addition in the boiler. Then after we expand it 3 to 4, that means expanding isentropic expanding in the low pressure turbine, right. So this is how it's look like in the TS diagram for the reheat Rankine cycle. So then we have an example. So I want you to pause the video and take some time and try it on your own. So the next video I will work through this example so you can follow it in the PDF that I provided. Right, I will upload this slides and as well as the worked example so you can follow it through. Right.